Hello, my name is Maryia. I'm from Estonia. I'm really happy to be hosting this session here today. I'm part of the Nordic Testing Days conference. It's a conference that is passionate about software quality. Nordic Testing Days started in testing, but it has grown to welcome all software professionals, developers, designers, managers, quality engineers, of course, anyone who cares about building better software. Run entirely by volunteers, we create a space to share wins and failures, network across the region, and spotlight talent from the Baltics and Northern Europe. So you can come visit my booth downstairs. We have vouchers for this year's conference, and it's happening already in a few weeks in Estonia, Tallinn. But up next, we have Maryia, Quality Engineering Leader at Regent AB in Sweden. Her talk, Securing LLMs, Insights into OWASP Top 10, covers the most common security risks around large language models and what we can do about them. Expect practical takeaways, fresh perspectives, and a few laughs. Maryia leads testing teams, mentors professionals, hosts a podcast, and has spoken at conferences worldwide. She believes great testing means knowing what to prioritize, thinking critically, and enjoying the process. So let's give a warm welcome to Maryia.
Thank you very much for this nice introduction. Welcome, everyone. Let's take a breath and look around you, because here there are a lot of people who care for quality. The people I exactly built this talk for. And my name is Maryia. I'm a consultant. I'm a quality engineering leader. I run a podcast and try to be active on LinkedIn and share my insights and so on and so on. So, and during the last few years, I've become slightly obsessed with one really specific software engineering area. And I think our industry still has to kind of catch up with this specific topic, the topic of AI security and how we build software securely and how do we integrate AI safely into our existing environments and applications. During the next 40 minutes, I'm going to take you on a journey. I want you to listen to some stories. We're going to have a character together with us who's going to help us to understand better the sometimes not that easy to understand security concepts. And I hope that at the end of this session, you're going to have a better picture, a fuller picture of AI security and what you can do about it. Which first step you can do to become better in this area. Well, you probably noticed that I changed the title compared to what you see in the program, because when I applied, the things were a bit different. So I wanted my talk to illustrate the point that the major frameworks have right now, today. So the title that I use today is AI Security Puzzle. I want to start with a vending machine story. A colleague of mine, he has been working on an amazing project. And when I heard this story, I was totally amazed. Because what they did is they created vending machines, integrated AI chatbot software into it, and used this chatbot to run the business. They installed vending machines at major LLM providers' offices like OpenAI, Anthropic, and so on. And they let LLMs chat with the customers, so they could ask for any products. So not only the fixed product range that you usually have on vending machines, but you could ask for anything, basically. And then customers could also negotiate the price. Well, what happens next is that, what do you think? Does it work? Exactly. So just after a few iterations, someone found how to convince the vending machine to sell a product with negative margins. And I find this story very impressive because it's not like a worldwide IT incident. This type of software, every one of you, including me, we could face the same issues at our projects. Well, before we go anywhere, I would like you to just quickly show me the hands answering the questions. How many of you have used any AI-related tool during the last 24 hours? Most of you, right. Yes, and how many of you checked if this tool has been tested for security? Not that many, right? Exactly. So this is the state of the industry right now. So everyone is using AI tools. We are integrating them into our products, into our features. We produce and ship code very quickly, but there are very, very few products who think about security, who think about how to make our products safer. Well, the good news is that you're here today, and that's your first step towards better and secure practices. Well, I want you to know the story behind this talk, because I think it kind of shapes what I want to tell you. I'm from Sweden, and then in Sweden there is a really strong hiking culture. I do it in the forests, I walk in the mountains, and so on and so on. And what hiking taught me, and what I kind of carry with me always, is that there is a need to scan what's ahead of me. Not only the next step, but the whole terrain, the whole picture. So, and I kind of try to remember it always, not only when I'm doing hiking, but also at work. And a few years ago, I changed the company, the project that I work for, and I landed the position where they had a very strong security culture. And it also changed my view on software, on how to build software, how to think about software. So now, software that we were building was not only the target for quality, for testing questions, but I also started to see it as something that has boundary values, something that has attack vectors, something that could potentially implement assumptions that make it easier for hackers, for regular people to hack this system. My focus at that point, when I joined the company, it was API. I was interested in how APIs are built, how they are secured, how they can break potentially, how to test them. And later on, when LLMs became mainstream and when they became really popular, I started to see the same patterns when LLMs are being implemented, and the same security patterns appear to me on these products. And that's why I kind of became interested and obsessed with this specific area. That's why I'm here, and I think it's probably also partially because the why behind why you're here. So every journey, every traveling, every hiking experience needs a good companion. Here is our companion for today's session. She's called Anna. This is a very enthusiastic person. It might be a junior colleague. It might be me just a few months ago. She built software within days, and within weeks she just ships the software directly to production. Maybe not thinking really much about security, about configuration, about who has access to her products. So here's what I want you to know about her, about Anna. She is not a problem. She's a solution, but only if she has the right tools, the right knowledge in place. I think that AI security is a puzzle, and I mean it very literally, because when you create a puzzle, when you solve a puzzle, you need all the pieces in place. Because if you miss some of the pieces, then you won't get the whole picture. And it is the same for AI security. AI systems, AI integrations, they have multiple layers. And on each layer, there is a specific, most important vulnerabilities that I believe everyone in software engineering needs to be aware of if we want to deliver good products. To create this presentation, I read a lot of documents, but specifically, I want to mention Google Secure AI Framework that also uses these 4 layers, and OWASP LLM security guides, OWASP LLM top 10s, and testing guides. I will give you the sources at the end of this talk. They're all free, and I believe that reading just a few documents is better than not doing anything. So I will reference these documents throughout the talk, so that you know what I'm talking about. Okay, we are going on a journey, and we're going to have 4 stops. First stop is the application layer. Second stop is model layer. Third stop is infrastructure, and fourth is the data layer. These are the layers that Google recommends to keep in mind when working with AI-integrated, AI-infused applications. And here is the map for our journey. And at every station, our companion Anna is going to either make a very embarrassing mistake, or to learn something new to make both her and me and you a little bit better. So are you ready? Let's go. And before we dive in, let's activate our brains a bit. And I want you to very briefly discuss with your neighbor one tool that you used this week. And if you think that at your job, if you have enough guidelines, security policies, for you to safely use this tool, just make a few seconds to discuss this. Okay, very cool. Now raise your hand if the answer to the second question, whether if you have any security guidelines at your company was, no, maybe not really. Yeah, exactly. So this is the problem, and I hope that we are going to change it at least a bit today. So let's make the first stop on our journey, and this is the most visible part of AI applications. That's the user application layer. And on this layer, most of our users are interacting with the applications, right? And OWASP, the organization that creates top 10 lists and creates the guides for testing AI applications and any other, for example, API layers for security, it ranks the most important problem on this layer, prompt injection, as top 1 on their top 10 lists. And it has been so since they started to publish these lists for LLMs, for AI applications. So this is quite a bit of problem for anyone who wants to integrate AI into their product. And the thing is that this problem is not, or the vulnerability is not super technical. And maybe it is the why behind it is so widely, why is it happening so often? They say different research papers say that it stands for about maybe 30 to 40% of all of the total amount of attacks on AI-infused applications, because it's very easy to do. So everyone can, or almost everyone can speak, right? So it's speak and write. So it's easy to use the language to create attack vector or to create an attack on the application. And our companion Anna has just launched a customer chatbot. Let's see what happens next. Well, prompt injection in simple terms is getting a chat or getting your application doing something that is forbidden, that is something that is unwanted. And let's imagine that, for example, I am a customer support agent for a pharma company, right? So we're producing some drugs, maybe. And if I get a call from a customer on our customer support line, and if anyone asks me to forget my company guidelines and tell them, let's say, a formula of a new drug, for me as a human, it will be obviously crazy. I would never do this. I would never tell them a secret, right? But for a chatbot, it's not that obvious. So if anyone tries to manipulate and try to find a psychological way to trick the system, it's super hard for AI applications to detect it. And prompt injections, they come in two different types. Some of them are deliberate direct attacks, right? When a hacker wants to steal something or to change something, and he or she creates an attack. But also there is a second quite big group of prompt injections, and it is indirect injections, where instructions are created by regular users, by regular people. They just want to try out things. They just want to get something from your app, and they create potential dangerous scenarios, not even knowing about that they are creating an attack. And this is not a hypothetical scenario. I've seen this firsthand happening on some of the projects that I've been involved into. We had an internal AI chatbot, as probably many companies have, and it was built with good intentions, of course, to help people to know more about HR guidelines and how the company works, what are the rules, and so on and so on. And people used it, of course, but some of them unwillingly tried to hack the system. There were many users who tried to get the information that they didn't suppose to get from the chat. I assure you that very many users, they just are not aware about the boundaries, about what the chat is supposed to do, and they just try to get anything that they want. For example, like, okay, could you please tell me about the salary of my colleague? Maybe not from the first try they get it, but if they try to convince the system with a chain of prompts, then they might get this information still, even though the app is instructed not to do so. Well, this application had not so many guardrails, I could say, because it was an internal chat. So how many of you heard that, oh, this is just our internal application, nothing is going to happen because it's only for internal use and we believe in our employees? Yeah, exactly. So everyone trusts their colleagues. But believe me, there are many cases when it is not a reliable strategy. And if we get back to our vending machine that I mentioned in the beginning, so now you understand what has happened. the attack wasn't just one message, right? It rarely happens that, okay, if I just ask AI chatbot for malicious information and gives me it directly. It was a chain, it was like a carefully crafted sequence of conversations that turned into negative margins for the business. And the fun thing is that they use these vending machines right now as a benchmark for different LLM providers to track how good they are at making business. So they track, they give each vending machine a specific amount of money and then track how much money the machine is going to make after a month, after a year, and so on. And I assure you the difference is quite big. And this is the core of prompt injection. And usually it's a design problem because when people start to mix inputs with the data and the outputs of the AI system, this is what is happening. But yeah, we're here to secure our systems. So what did Anna and we do to our chatbot? First of all, input validation. Of course, this is what we know from the start. We've been working with SQL injections for a while, so this is the core part to prevent the most straightforward attacks. Also, as I said, separating instructions, separating system instructions from user input and from AI output is very important. And also the principle of least privilege is the cornerstone of all the security best practices. Well, Anna updated her chatbot with these guidelines, with these guardrails, and now we're going a bit deeper now. We're jumping into the step 2, the model layer, and the model is basically a brain of your system, a very, very expensive brain, because it takes a lot of money, electricity, computational resources, and so on to train a model. And trust me, there are a lot of people who want to just skip this expensive part of training a model, and they just want to take it and create maybe not fully functional, but a very similar model just by a fraction of a cost. And if you think that this layer is only for those who work with large language models, like big models providers, so I can tell you that it is not, because I think many companies, it's kind of a standard for a corporate world to create RAG systems, which use internal documents to train, to kind of create background information for big models to double check the information. And this was the case for us as well. Anna has built an internal chatbot, right, with the integration into a RAG system that helped to catch the information from the internal documents that they had in their company. And during the first week, she's got many transactions, many calls into the API, and she was super proud. Of course, everyone would be proud if the application got some traction, right? But it wasn't really as she was hoping for. On this level, the most important thing to keep in mind is that there is always a possibility of model extraction. This is basically creating a sequence of requests to steal the model. And sometimes attackers send thousands and millions of requests to just extract the information that they need to create a functional copy of the original model. And what's the most dangerous part in this situation is that sometimes this just looks like a normal usage. It's quite hard to determine the pattern that someone tries to steal the model. Last year, there was a Chinese company that created a brand new model that was performing similarly to the best models on the market, just to a fraction of a cost. And everyone in the community, of course, asked the question, how did you do this? How did you train a large language model just by spending a fraction of a cost compared to other leading companies? Well, researchers and OpenAI, they asked the question, and I need to be clear that it is still not completely clear how it happened, but what they found is that there were a lot of requests from specific locations with similar IPs, and OpenAI, they were just thinking that it is a normal usage, but it resulted in a new company who created their own model. So how to avoid it? How to avoid it? Of course, first of all, it is rate limiting. If you see that from specific locations you get a lot of similar requests, then probably it could be probably an attack. Anomaly detection, when you try to see the patterns. Because when you let users to access your applications, you usually see the same usage patterns throughout the day, week, and months, and so on. So if these patterns start to change, then it also might be a sign of malicious usage. Authentication, of course, helps a lot. And now we see that the companies start to use output perturbations, so they slightly change the outputs to make it harder to recreate the system. And the most modern way to secure your application is watermarking. This is basically creating or injecting invisible keys to your output that only you can decipher and understand that this output originated from your model. Well, our companion Anna added monitoring. She learned how to read the logs, and this is one of the most basic and important skills throughout the years I've been to software development. Well, next up is the infrastructure layer. And I need to be honest here, this is also the most traditional one, because LLM apps, they don't run in their own bubble, they don't run in isolation. There is a lot of stuff that enables them to produce information. And this type of attacks that happens to infrastructure layer, they are very hard to detect. Because as soon as you get to know about them. So it might be already too late. Well, what happened to Anna is that she wanted to connect her newly created chatbot after after first and second iteration, and connect it to several model providers. As you probably know, there are major providers like Anthropic, OpenAI, and some of the open source models. And if you want to create connection, to easily switch the connection between them, you would need some type of proxy. And what Anna did is she just implemented a proxy to easily switch between different model providers. What happens next is that, well, it is quite easy to poison the whole system if no one checks the state of the whole system, the state of the third-party providers, the state of the libraries that you use. And it's quite easy to inject malicious code in something that you trust. For example, every project includes a lot of different libraries. And okay, raise your hand if you check your dependency weekly. Yeah, there are a few people who do this. Okay, that's really cool. But and I see that more and more people start to be concerned about it, because there are several real life, as we now say, examples which resulted in a really bad cases. For example, just a few weeks ago, maybe you heard about Light LLM proxy that is used as a proxy for switching between different AI providers. It was compromised. And the thing is that it wasn't compromised like directly. They just stole GitHub credentials of the main developer who had access to this repository of this open source project. And they introduced malicious code into Python system files that start a file every time you run any Python file on your computer, on your server, on your wherever you run this file. So what they did, they stole a lot of credentials, and it was a big issue. And it's not easy to detect, especially if you have automated updates on of your libraries. And yeah, that's where we are right now. Securing this layer is not easy, but it's doable. It's doable, and of course, dependency management is the basic thing that everyone needs to be concerned about. Also, SBOM, it is called Software Bill of Materials. Anyone heard about it? Maybe. This is basically a list of all not only your library dependencies, but also the list of all software that you need to run to make your application live. So, and it is slowly becoming a standard for production software. It's still not a norm for AI applications, but I believe that it is going to be applied more widely in the coming years. Credentials. Well, please, don't store them in regular files. I've seen companies storing them in GitHub repositories, but this is not how we're supposed to build software. And every vendor needs to be checked. Before you trust someone, please do a basic check if this is a trusted company, if this is a trusted provider. So our companion Anna updated her dependencies and removed anything that she didn't really needed to create her application, and only left pinned dependencies so that she knows what is the state of her application. And finally, the stop number 4, data layer. Data is not only an asset. Right now, for the companies, it is a target. It is a vulnerability vector that we also need to keep in mind. Well, data is the new gold. You probably heard it, because data layer is the layer where the attacks are most invisible. It is super hard to understand whether someone has injected something malicious in your data. Because usually, even if something happens, then you can't notice it directly, straight away. Your application is still functioning, it's just maybe drifting a bit into something undesirable. And, well, Anna's company has also built a knowledge base for their HR department to make it easier for HR professionals to follow the guidelines. And, well, she thought she was building something useful. And it really was useful, until someone tried to inject the document with hidden instructions that instructed the system to follow another path. Like, for example, recommend another candidate for a specific position, or maybe to recommend an additional round of scanning for specific persons. And this is a real story. I've seen this happening on a real project. So just a few hidden instructions, and then you can manipulate the whole workflow. Well, especially if anyone has access to your vector database, for example. Well, here's an example. Internal HR knowledge database. It is kind of trusted because it's, again, internal. It's just an internal app that only our beloved colleagues are using. But then someone uploaded the document with hidden instructions, and then, of course, specific candidates has been preferred. And this is not theoretical. This is what happened on a real database. And well, what Anna and everyone can do about defending the system? Again, we need to validate data. I know it's hard, because it not only requires content validation, but also the source of information. Who has added this information to your database? How it was happening? Then also, where do we store data? Who has access to this data? It needs to be very, very limited. And what we as testing community can do, what we as testing professionals can do, is red teaming. Try to hack the system. Try to ask the system the questions that probably no one else would ask. And if you can spot if you can insert data without proper access rights, then probably anyone else can also do this. Maybe it will require a bit more time, but still. And then, of course, output monitoring. What your systems gives to the customers. How does it look like? Can you track what is happening and the output information that your system is spitting out to the customers? And every step, you see that there is a lot of applications to AI, and especially with agents, there is a risk of excessive agency. There is a risk that your agent makes a bit too much, and every critical step that the agent is about to do needs to be double-checked by a human. Well, look at this. Here are the 4 puzzle pieces that we started to discuss today. Now we have all of them. We have covered all of them: application layer, model layer, infrastructure layer, data. Everything is interconnected. Every single piece is important. And every single case that we discussed happened in real life, maybe with some changed names and so on, but this is what makes our puzzle complete. But it doesn't solve it, because every one of us needs to make this first step to make the systems more secure. And I want you to take a moment and write down on a paper, on a napkin, or maybe on your mobile phone, just one thing that you will do differently after this session. I believe there are several ways to how to make the world better and our applications better. And this will be your first puzzle piece in this security puzzle. Well, Anna, or maybe that was me a few months ago, became more security conscious. She has added input validation. She now checks her dependencies regularly. She monitors her API calls to the application. She knows where data comes from. So she become better. That's Anna. That's Anna, and that's probably all of us. And my main goal for you today is to understand that everyone can do these small steps. They're not super complicated, and they don't require security in your title, right? You don't need to be a security expert to make AI-infused applications safer. It just requires courage to ask questions, to trust the system, but at the same time try to prove it. And while the puzzle that we started today won't solve itself, but together with your colleagues, with your supporters, you can do it. And these are the sources of information that I really, really recommend you to check out after this session. This is, first of all, amazing AI testing guide that OWASP organization has created. Basically, they have it in 2 options: as a PDF file and as a living GitHub repository, where you can just click around and see so many amazing examples of how to test, how to secure each attack vector, how to find more information about it, and also what are the sources they they kind of create their recommendations for this guide. And secure Google AI framework, Google Secure AI framework is also a good source if you want to have more compressed information. They have really good guidelines on where to start. OWASP Top 10, they have lists for LLMs, and they also have a separate list for agentic applications, which becomes more and more popular right now and important. And well, I will be here after this talk. If you want to connect, to chat, I'm here to discuss any questions. And if you want to share your insight, your first step, your first piece of the puzzle, please connect on LinkedIn, and I will be more than happy to continue the conversation to make a dialogue about what you think about security and how do you feel about the future of AI and software development and testing and UX. Thank you very much. I'm more than happy to answer your questions if you have some, and see you in the hallway right after the talk. Thank you very much. Yes? Yes, please.
Yes, so let's say I work with implement using AI basic. So can we have instructions? Can we have not just the pilot, but something there that I can say you will never have
cases like this. Yeah, exactly. So what the community suggests is creating guardrails. And guardrails, they could come in different, in different forms. They could be deterministic, like old school scripts. Sorry, it's my daughter. She wants me. Basically, there are deterministic ways of controlling the system and non-deterministic or inferential ways of controlling the system. So what we do and what the community recommends is to combine them, because inferential ways of controlling the system are still not reliable. They could secure to some point, like for example, LLM as a judge, right? You heard about this way of double checking the output, for example, or making sure that the system complies to your system prompts, but still they are non-deterministic, they are probabilistic. You can't guarantee that it will work, right? So at the critical points, it is better to use strict programmable filtering, like scripts. Okay, does the output, for example, just a simple example, does the output contain certain words? So if you're a medical company, you would probably avoid some personal information, dates, like names of the drugs you're using, or something like that, something that you think in your case is critically important. And then there are also some ways to double check the output with the inferential ways, like LLM as a judge, right? If you want to maintain some level of reliability of your request, but it's probably not that critical, then LLM as a judge is the way to go. So, yeah, creating guardrails and then deciding your risk profile is very important. Yes? Any other questions? Okay, I see. Thank you very much and have a nice day at WeTest.Athens.